Hi all, in this last lesson on data extraction we're going to treat process modification and the plus-minus principle. In heat integration studies you normally respect all conditions of temperature at the entrance and outlet of every device, of every unit operation. But sometimes, especially when you are designing from grassroots a process completely new, you can think in modify the process, the operating condition, in order to improve the energy balances and reduce the requirement in utility and equipment. Even if you are retrofitting a process, changing it, you can think in the constraint, in the condition, as hard or soft, or flexible or rigid. Some of them can be more easily changed, as vaporization or condensation pressure temperature, the temperature of streams that goes to storage, or the pressure temperature of column, the reboiler and the condenser. The most common process modification possibilities then are the pressure in distillation column, the pressure of the vaporization of feeds to devices, the flow rates to pump arounds, and the conversion of reaction or the recycle rates. In order to identify changes that are good at words in a process flow diagram, you can use the plus-minus principle. This is a general abstract principle that can be seen in the T versus enthalpy diagram. Following it, good modifications are those that decrease hot utility, increasing hot stream duty above the pinch or decreasing cold stream duty above the pinch, or those that decrease cold utility. It is decreasing hot stream duty below the pinch or increasing cold stream duty below the pinch. This can be done also by changing temperatures, but this change must be across the pinch. Changes of operating temperature limited to one side of the pinch have no effect on energy targets. A change in temperature have effect on energy target only if she shift duties across the pinch. It is shift hot stream duty from below to above the pinch, or shift cold stream duty from above to below the pinch. As a general rule, good modifications are those that made hot stream hotter and cold streams colder, because they can shift duty the right way and also can widen temperature approach between curves and so improving driving forces, reducing the size of heat exchangers. Here you can see an example of a process with two columns, condenser and reboiler 1 and condenser and reboiler 2. The pressure of column 1 has been augmented, and so the temperature of condenser 1 and reboiler 1 has increased, allowing condenser 1 to overlap partially reboiler 2, recovering then more heat. And this is all for this lesson and for data extraction.